Right. Good morning, everybody. Welcome to Ketzbook Live Physics. And let's see, how's everybody doing this morning? It's snowing a little bit outside where we are, and a little bit surprised about that. But hey, you never know. Nothing too crazy is going on these days. All right. So let me just see who all's there. Say hi if you're there. And let's go ahead and just jump into things on the review. So again, we're going to have a little test tomorrow, not the same size as, let's say, our normal test, but we will be having a test tomorrow, test quiz, all that kind of stuff. And we just want to go over problems that are going to be similar to the ones on the test, and let's just jump right into it. Okay, so morning. All right. So let's just start over here with the multiple choice. Okay. So you guys all had the multiple choice problems. We won't have multiple choice on the actual test, but the concepts that are in the multiple choice will be there on the test. So let's just go ahead and jump into this here. Number 5, how is conservation of internal energy expressed for a system during an adiabatic process? So we remember that adiabatic means what? Adiabatic means that your Q is 0. Okay, so the first thing you're going to look for here is Q is 0, and you see that for B, Q is 0. And so if Q is 0, you also know that your delta U is Q minus W, right? So if delta U is Q minus W, and we know that Q is 0, that means that delta U is going to be equal to negative W, right? So that's going to be B for number 5. All right, number 6. How is conservation of internal energy expressed for a system during an isovolumetric process? We remember for the isovolumetric, because let me push this down even more, because your work for some kind of volume tight system is P delta V. Isovolumetric means what? It means that your delta V equals 0. So delta V is 0. That means your work is going to be 0. So we're looking over here for something like that. And we see that all the way down here in D, that delta V is 0. So P delta V is 0. And work equals 0. Therefore, delta U equals Q. And we notice that if work is 0, your delta U is going to equal Q. So that's exactly what we're looking for. So 6 is going to be D. Okay? Now, interestingly enough, the next problem deals with exactly that same situation. So an ideal gas system undergoes an isovolumetric process. So we have isovolumetric. And so in isovolumetric, all these things are true, in which 20 joules of energy is added as heat to the gas. So that tells us that what? Your Q is 20 joules. And the question asks us, what is the change in the system's internal energy? So they're asking for delta U, and we already know that delta U equals Q in an isovolumetric process, so that's going to be 20 joules also. And so not negative 20, but 20, so 7 is going to be D. Okay, so that's the multiple choice for these. Let me see if you guys have any questions. I know there's not a lot of you guys on here, but let's just pause there with the multiple choice and see if you guys have any questions on those. So just let me know right now. I know there's a little bit of a time lag here, but let me know if you guys have any questions on the multiple choice. You guys seeing the snow? It's a little crazy. I guess it is still March, but we've had such a warm winter that it's kind of funny that we're having snow today. Okay, so no questions, at least as far as I can see. We're going to go ahead and jump right back into the review problems, and we're going to do 3, 4, and 5. And let's go ahead and tackle those. Drag this. Okay. So number 3, it tells us we have a total of 198 joules of work is done on a gaseous refrigerant. And so let's just go through those. And as you're going through the problem, make sure that you are identifying what everything is, making sense of that. So the first thing we're going to write down for number 3 is that a total of 190 joules of work is done on a gaseous refrigerant, right? So our work, in that case, is negative 198 joules. Why negative? And this is key because you might end up with something like this in the test. Why is it negative? We have two things to tell us that this is going to be negative. First of all, it says that work is done on the gas. When work is done on the gas, that's going to be negative work because positive work is work being done by the gas, at least in terms of the equation that we are using. And basically in terms of physics, we're going to identify work done on the gas as negative work. And then secondly, it says that the gas is being compressed, right? So that compression that we see in the problem means that that your delta V is going to be negative, and if delta V is going to be negative, that means your work, which is P delta V, is also going to be negative, okay? So both of these tell us that the work is negative in this case, and that's going to tell us that the total work is going to be negative 198 joules, okay? So next up, if the internal energy of the gas increases, so we have a positive delta U, it increases by 121 joules during the process. Now it says solve for what's the total amount of energy transferred as heat. So we're solving for Q, and that we know the equation delta U equals Q minus W. And so if we're solving for Q, we're just going to add W to both sides. That gives us a Q equals delta U plus W. I just added W to both sides and switch sides, so it gives me Q equals delta U plus W. And then we could just put the numbers in, okay? So that's going to be, for U, we have 121 joules, and W that's going to be a negative 198 joules. So we're going to subtract the two numbers, keeping in mind that our negative number is larger. And so if the negative number is larger, that's going to give us a negative number for Q. All right, so it's going to be 121 minus 198, and you can put that in your calculator, or you should just be able to do it in your heads. 198 minus 121 is going to be 77, and once again, the negative number is larger, so that's going to be negative 77 joules. And that's going to be the value that you have for Q here. And let me just refresh. My screen is gone blank here, so I'm going to refresh that because I can't see if any guys are asking any questions. Here we go, that worked. Any questions on that so far? Okay, I'm not seeing any questions at all. You can write your answer as negative 77. That's probably the best way to say it. Or alternatively, and equally accurate, you can say that 77 joules of heat is transferred out of the system or out of the refrigerant, something like that, okay? But ideally, probably the best way to answer it is just as negative 77. Makes it really, really clear that you know that this is a Q is negative process. All right. So, so whenever a problem says work done on a gas, it will always be negative. Yes. Whenever work is done on a gas in this class, the work is going to be negative. Okay. Now, just keep in mind that unfortunately, not everybody in the science world defines these equations and defines the positives and negatives the same way. But for now, for the equations that we're using, right, for this equation where your delta U equals Q minus W, work done on the gas is negative. Okay? Other questions? Okay. So next up, let's go ahead and tackle number 4. And we'll go ahead and switch to black here. Number 4. Okay. We have the internal energy of a system is initially 57 joules. So the internal energy, that's going to be, and this is a variable that you're not typically going to be using, but we do in this case. So this is going to be the initial value for U equals 57 joules. And so that can be a little bit confusing, but pay attention to the wording, right? It says the internal energy of a system is initially that value, all right? So that's not delta U. That's the initial value of U, okay? And so actually, the hardest part about these problems is really just identifying what's what and identifying what's positive and negative. So make sure you pay attention to the wording, okay? So the internal energy of a system initially, so the UI is going to be 57, and a total of 84 joules of energy is added to the system. So that's going to be Q. So Q is 84 joules. And heat, let me see, while the system does 62 joules of work. So the system is doing work. So work is going to be positive in that case. 62 joules of work. So everything's positive here. What is the system's final internal energy? So UF, that's what we're solving for. That final internal energy, that's what we want to know. Okay. So clearly at this point in time, we're thinking that we want to solve for delta U first, right? So you can get U final if you get your delta U. And so we're going to solve for delta U because we have both Q and W and we can do that, right? So we remember that delta U is simply going to be Q minus W. And so we can plug in some numbers there. So that's going to be 84 joules minus 62 joules. And once again, we could probably just do that in our heads. 84 minus 62 is simply 22 joules. But that's not the final answer, right? That is delta U. That's not the final answer. So the final answer, we have to go back and solve for UF. So we remember that any kind of delta is going to be final. Oh, well, let me see. Sorry about that. So any kind of delta means your final minus your initial. And so now that we have the delta U and the initial, we can now solve for your U final. Just add U initial to both sides. That's going to get U final is going to be delta U plus U initial. And so that's a delta U we said was 22. And the initial value we said was 57 joules. And so we just add the two together and I'm running out of space here. But when you add the two together, 22 plus 57, that gets us a final value of internal energy of 79 joules. Okay. So any questions on number 4? Probably the main thing is just figuring out what's what and not forgetting the fact that your delta means final minus initial. So we got positive values for pretty much everything in that. And it makes sense, right? Because if you're starting off with 57 joules you're going to increase it by a certain amount, it makes sense to have something larger here for the final value. Okay. Any questions at all? All right. So last problem. Oh, that got kind of messy. The last problem that we have, if you can still read that there, is going to be number 5. We have a steam engine, and we have this is a cyclic process, and we have a value for QH and QC. Okay. So for number 5, right, this is going to be a cyclic process. And so it says a steam engine takes in 2.54 times 10 to the 5th joules of energy. And that's going to be your Q hot, right? So because the engine's taking in that amount of heat, that's going to be the initial amount of heat, 2.54 times 10 to the 5th joules. And, well, how do we even know that that's Q hot? If you read in the problem more, it says that it exhausts a certain amount of heat. So as soon as you see that word exhaust, automatically you know, okay, there's 2 different heats here, and that second heat is going to be Q cold. Because Q cold, which is a little bit easier to identify in this case, we're going to identify Q cold from the word exhaust. Okay, exhaust is always going to correspond to Q cold. Okay, so it's going to exhaust how much? 1.75 times 10 to the 5th joules. Okay, so this is the amount of heat that's being burned in that cyclic process. It's going to be used by that engine, and then it exhausts this amount of heat. The difference between those is going to be theoretically the amount of work that engine can do. And so we want to calculate what its efficiency is. Now we could, go about this some kind of long way, but there's no point because we already have the equation where the efficiency is going to be 1 minus Q cold over Q hot. We don't need to reinvent the wheel. We don't need to make up this formula. We already have this equation. So let's go ahead and plug in some numbers, and that's going to be our efficiency. Okay? So we have 1 minus 1.75 times 10 to the 5th over 2.54 times 10 to the 5th. The first thing that we notice is that we have 10 to the 5th on the top and 10 to the 5th on the bottom, so we honestly don't need to worry about those. 10 to the 5th over 10 to the 5th are going to cancel each other out. So you could put this in your calculator just like this, but also you can just do 1 minus 1.75 over 2.54, and that's going to be fine too. So for this one, this is not going to be a mental math problem for me, so I'm going to go ahead and break out my calculator. All right, and we're just going to type it right in there. That's going to be 1 minus 1.75 divided by 2.54, and hit enter, and we get this number, and you can use this as your final answer. This is fine, 0.311, or if you want to make it into a percentage, that's going to be 31.1% efficient. Either one, you can just stop at 0.311, and that's a fine answer. Okay, so I see a question here, and Q hot is what is taken in from the reaction. Yes, Q hot is what is taken in from the reaction. Okay, although the wording for Q hot might vary, that word exhaust is going to be pretty indicative that that's Q cold. You might not always see taken in for Q hot, but something along those lines for Q hot, that the heat generated in the reaction or heat that's taken in or heat that's absorbed, something like that for Q hot. Okay, so open book test, right? So the equations are not going to be a problem. I highly suggest you guys to have all the equations written down on one sheet of paper somewhere. I'm not going to do that for you guys because I know you guys can do it yourselves from the homework that you guys have done, from the reviews that I've done, from all this. You guys have a bunch of equations. And so make sure you have those written out while you're taking the test because you're not going to have a ton of time. All right, I have another question. So for this problem, we do 1 minus 1.75 over 2.54 instead of 1.71. It's the same thing. Either way, order of operations in your calculator is always going to be doing the division before the subtraction. So it doesn't really matter whether you have parentheses there or not. Yeah. Can we have our review sheets out during the test? Yes. Yes, you can. I know. It's gonna make it easier. You can have your review sheets out during the test. Okay? Obviously, they're gonna be different problems, but they're gonna be similar problems. You're welcome to have your review sheet out. You're welcome to have your book out. You're welcome to have an equation sheet out. I recommend having an equation sheet just because it's going to be easier for you to just look up the equations right away from the equation sheet. But you only really need the equations for this particular chapter, so it's not a whole lot. So I would write them down on a separate sheet of paper. Okay? ONVRM. Okay. Yeah. So anyway, you guys can use your notes for this. You guys can use your book for this. The one thing that you absolutely cannot use is you may not talk to each other during the test at all. You may not ask anybody how to solve any of these problems. Obviously, that would be cheating. Hopefully, I've made this easy enough for you guys that you don't need to cheat and you can still do really, really well on the test. Okay? How many questions are we looking at for the quiz? I'm looking at, I think, so there's going to be no multiple choice. I'm thinking probably 4 questions. And some of the questions might be, let me see, some of the questions might be similar to some of the questions on the multiple choice, but they're all going to be free response. So maybe like a combination of a couple of these for the multiple choice in some kind of free response type question and free response questions. We're looking at 4 problems, 4 free response problems, and that's it. Okay? Now, when you're taking the test, this is going to be the first time that you guys are going to do this. So your time is limited, and it's important that you log in at the same time. So you guys that are actually listening to this live stream are not going to have a problem because you show up to class on time. And so this is mainly for everybody else that's going to have a problem. You have to wake up on time. You have to come to class on time. I might even post it a little early. So you can look at, whatever, 7:40. You might see the test there by 7:40, and you can open it up, right? But it's going to be due at the end of class, which is, I even forget, what is it, 8:33 or something like that? No, 8:32. So the test quiz is going to be due exactly at 8:32. And if you turn in late, you're going to have a problem. Okay, so make sure that you finish it on time. It's going to be plenty of time if you wake up on time and do your work. So you can either print it out or you can do the problems on Notability. And then make sure you upload it to Google Classroom. Now this is just a worst case scenario. If you somehow have a Google Classroom error and are unable to upload it, go ahead and email it to me before it's due and say, Mr. Katz, I can't upload it. So here you go. Here's my test on email. Okay. But please upload it to Google Classroom instead of emailing it to me. Okay. So do we print the test and then do it and upload it to Google Classroom? Yes. Alternatively, if you want to do this fully digitally, you may, and you can just do it on Notability. But if it were me, I would do it on paper and then upload it to Google Classroom. I think that's going to be an easier way to go about this. But you can do it either way. So yes, that's exactly what you do, Jordan. Other questions? I think you guys are going to do fine. I know it's going to be your first one, so it's going to be a little bit, different. But expect problems, like the review. Pay attention to the wording. My wording won't be exactly the same as the wording on the review, but think about it. Pay attention. Look out for those key words. Look out for things, talking about things done, work done on gas, work done by the gas, expand, compress, words like exhaust, that kind of stuff. So pay attention to those keywords and make sure that you are able to deal with all these things: isovolumetric, adiabatic, isothermal. You haven't had any isothermal problems, but you should understand what that means, right? Isothermal means that there's no change in temperature, which means for isothermal delta U equals 0. So be familiar with all these terms, even if there wasn't specifically one on this review. Things like isothermal, there might be a problem that involves that. Isobaric, you're not going to be something that you're actually going to be using. Isobaric didn't show up on anything that we learned, but it's going to be a constant pressure kind of thing. But you won't have a problem like that. But isovolumetric, adiabatic, isothermal, you should be familiar with those. Okay. Another question: work done by a gas is positive. Yes. Yes. Other questions? Okay. If there are no further questions, we're just going to stop right there. Hopefully, you guys, hopefully this helped for you guys. Hopefully, you guys found that you got these problems right, and you know what to look for in the text. So, um, you know, you don't need to study a whole lot, but the main thing that guys need to do is make sure you're able to solve these kinds of problems. Make sure you understand what we talked about in terms of solving them. Have an equation sheet ready. Have your calculator ready, and I think you'll be fine. All right. So if there's no further questions, I'm just going to close out right there. And have a wonderful day, everybody. See ya.